Okay.
Oh no.
Okay, so today we are going to talk about inverse trigonometric functions. So as we've seen with any kind of function really, anything we've done up to this point, chapters 1 through 4, pretty much any time we have a function, we have to think about the inverse function. Because if we are trying to solve equations that have variables inside of some function, we need a way to undo it. So our functions need inverse functions as ways to undo them. That's why the squaring function has the square root function. That's why cube root has cubing. That's why exponentials have logarithmics. Okay, they're all ways to undo each other. So the same thing is true with trigonometric functions. We need a way to undo the trig function when our variable is inside of it. So we need inverse trig functions. Now, unlike the other ones, this does not really have its own name, like squaring and square root or cubing and cube root. This is trig and inverse trig. Okay? But inverse trig is not quite as straightforward as some of our other functions. So that's why we need to spend pretty much an entire lesson making sure we understand what we're actually allowed to do when we do inverse trig functions. Okay? So we're actually going to start out by looking at this graphically. And we'll come back to this table in just a minute as kind of a summary of what we're going to do here for the next few minutes. But if I show you this, what two functions am I showing you?
Sine.
So I'm showing you f of x equals sine and y is equal to x. Okay? Our straight line here has to be something linear, and the linear equation that's important to us when we talk about inverses is the y equals x line, because that's the line that graphically we have to reflect through to change an original graph into an inverse graph, right? Okay? So, in looking at this sine of x function that I've given you, if I try to take the inverse of it, is it going to be a function? Is the inverse going to be a function? Why not?
Because it doesn't pass the vertical line test.
Sure it does.
The inverse?
Yeah.
No, I'm talking about this.
Oh, this does.
This passes vertical line test.
But if you modify the inverse, it has to pass the horizontal line.
Aha!
Oh, I thought you were saying
That's the problem.
the inverse.
Okay? And the reason we use the horizontal line test on the original function is because of what Jonathan's saying. Because when I do the inverse and I do that flip over y equals x line, if this doesn't pass the horizontal line test, then when I make the flip, it's not going to pass the vertical line test, which means it's not going to be a function. But we can determine that before the flip by using the horizontal line test. And this one fails miserably. Right? Okay? So, we're not going to be able to just flip this over and go, hey, there you go, there's inverse, see ya. So, I want you to think outside of trig for a second and tell me another function that you know of that we've already talked about in previous lessons, previous chapters, that also failed the horizontal line test, and yet we still have an inverse for it. X squared. Okay? So y equals x squared is a graph that looks like this originally. Más o menos? More or less. Sorry. I know way more Spanish than Chinese, and that's not very much, but okay? But if I were to use just this parabola and then look at the horizontal line test, it would fail. And yet, x squared has an inverse function. It's square root. So what did we have to do to our original x squared parabola in order to make it something that would work with the horizontal line test and would work when I took the inverse of it?
Switch x and y.
That's actually doing the inverse. I got to do something to this beforehand before I do the inverse so that the inverse will work.
Are you assuming x is positive? No. I don't know.
You're on the right track.
Not taking plus or minus, just taking the square root. But I don't know.
Okay, so what do I have to do to this, the original function, so that when I'm ready to take the inverse of it, the inverse will be a function? In other words, what do I have to do to this to make it pass the horizontal line test?
Cut it in half.
Cut it in half, which mathematically we call limiting the domain. Okay, that's the fancy way of saying cutting it in half. So what we did was we took the original function that failed the horizontal line test and we limited the domain down to the part of it that would pass the horizontal line test. And then just using that part, we could then take the inverse and work with that. Which is why when we take the square root of x graphically, we only consider the positive answers. Okay? Because what ends up happening now is that our domain, which originally was all real numbers, has now been limited to a domain of 0 to infinity. Right? And our range originally was what?
0 to infinity.
So what is it now?
0 to infinity.
Yeah, that part didn't change, right?
Cool.
I'm still starting at 0 and going up from there. It's just I only have half of it. But then what happens when we do the inverse, when I actually do this flip and I end up with that graph, now what's the domain for square root?
That's bracket 0 to infinity.
And the range?
Bracket 0 to infinity.
And the reason is because we're taking this, the domain and range of this limited x squared parabola, and we're flipping that to get the new domain and range for x squared. Now it's hard to tell because they're both
Yeah.
the same, but technically,
If,
inverse is all about switching x and y. So part of that is whatever domain and range were for the original, I switch that for the inverse. So not only can I only put 0 to infinity in for x, I can only use 0 to infinity as my answer as well. So I'm only interested in those positive answers when it comes to the graphing of it. Okay? So this is how we dealt with a similar kind of failing the horizontal line test situation in the past. So this is how we need to deal with it again now. We need to try to limit our sine function as little as possible. Okay? So we don't want to limit any more than what we have to. But we need to limit it down to something that's actually going to pass the horizontal line test. So how should I limit my domain so that I end up with a piece of the sine function that will pass the horizontal line test?
go from the minimum to the maximum.
So give me x values. What's my domain going to be?
negative x over 2 to x over 2.
Negative x over 2?
Pi over 2, sorry, it's really blurry.
Okay, so from negative pi over 2, which starts right there,
To pi over 2.
to pi over 2, which ends right there. Okay?
Inclusive.
So does everyone agree now that we have a piece that passes the horizontal line test? Okay? Could we include any more than that and still pass? No. Okay, so we've got as much as we can have and still pass the horizontal line test. Okay, so now we're still talking about f of x being sine of x, but now we're talking about it with a domain of what?
Bracket pi over 2, or negative pi over 2 to pi over 2 bracket.
Okay, and then what's the range of this piece? So again, notice my range didn't change. So I'm still including all of the possible range values when I limit things down. It's just the x values where I'm doing the restriction, okay? See if I can make this a little bit clearer. Is that a little better? There we go. All right, so now that I have the piece that I can work with, now I can make the flip. Now I can take the inverse. So I'm going to flip this over the y equals x line. And when I do that, I get this.
Oh, yeah. See what good.
Looks like the cubic.
Okay, so this now, whoops. Is what the graph of, sorry. Try it again. That was f of x, we'll call this one g of x. Here's how I wanted to write it. There. That's what the inverse sine of x looks like. This graph right here. Okay? Now, as the inverse, what is the domain of this inverse?
The opposite of the range, so negative 1 to 1.
All right, so there it was for sine. So what's it going to be for inverse sine?
Bracket.
Negative 1 to 1. And the range?
Bracket. Negative pi over 2 to pi over 2.
All right, because again, we're just going to flip-flop what we started with for regular sine. Okay, but also look at what's happening with our axes. My x-axis over here when it was just normal sine, these values on the x-axis represent what?
Measures around the circle.
So radians, and radians measure angles. So we're looking at angle measures as our independent variable, right? That's the input that we put into the sine function, and then our y-axis, our dependent, is whatever the result is. Okay? So when I make this switch, notice now that the angles are the y-axis. The angles are the range. The angle measure is what I'm trying to find out. So my input now are these numbers that are just, 1, 2, 3, negative 1, negative 2, negative 3. The input value to an inverse sine is actually the result we would have gotten from sine for whatever that angle was. And so what we're trying to do is we're trying to say, okay, if the sine of this angle had given me this result, then the inverse sine of this result has to come back and give me this angle. So when you're asked to find the inverse sine of something, what you're thinking is, what is the angle that if I had taken sine of it would have given me this number in the first place? That's what you're trying to come up with, is what is the angle. Okay? But the angle that we pick is restricted. Because my range for those angles now is simply from negative pi over 2 to positive pi over 2. Those are the only angles I can pick from for an answer. So I can't pick from the entire circle. I can only pick answers that are within this interval from negative pi over 2 to positive pi over 2.
So does that mean you're like looking for the reference angle kind of?
Possibly, that would be the positive part.
Yeah.
But I can go from negative pi over 2 to positive pi over 2. So negative pi over 2 would actually take me down into fourth quadrant.
Okay.
So really, if you think about the unit circle, for sine we're saying my answers can only be in the first or the fourth quadrant. From negative pi over 2 to positive pi over 2. So I got to get an answer that's either a first quadrant or a fourth quadrant answer. But the trick with the fourth quadrant is to realize it's not a positive angle to the fourth quadrant. It's just a negative angle to the fourth quadrant.
Mm-hmm.
Because of the way this range is set up, from negative pi over 2 to positive pi over 2. So those are the only kinds of answers I can come up with from an inverse sine. And that's going to be really important to remember as we start doing some problems here in a few minutes. Okay, does that make sense? Okay, so then our other trig functions are pretty similar to this. So let's kind of go through the same process here. So this is what function? Cosine. So how do I need to limit the cosine function to end up with a piece that passes, not understanding, but, sorry, those are churchy people, piece that passes understanding, you know, you ever get that blessing in church? The piece that passes the horizontal line test. Different piece, different test.
Limit the domain
0
from 0 to pi.
From 0 to pi.
Yeah. From max to min.
Okay, so we're saying this piece
Yep.
passes the horizontal line test. Can I include any more than that and still pass? No. Okay, so I've got as much as I can have and still pass the horizontal line test. The other thing to keep in mind is this is not the only piece that would pass, right? Like I could go from here to here and it would pass. I could go from here to here and it would pass. But there's this particular piece that is just mathematically accepted to be the piece, okay? So for sine, it's the one that's kind of around the middle, from negative pi over 2 to positive pi over 2. For cosine, it's the positive, from 0 to pi. Okay? All right, so we're saying now that this is the cosine of x. What is the domain now of this restricted piece?
Bracket 0.
0 to pi. What is the range? Okay, so again, my range didn't change on me. I'm just limiting which x values I can use. All right, so now that I have a piece that works, now I can make the flip to get the inverse. And so this is what inverse cosine looks like. And it's this piece right here. So what is the domain of inverse cosine? Negative 1 to 1. What's the range going to be?
0 to pi.
0 to pi.
0 to pi.
Okay, because again, we're just going to flip what we had for domain and range of regular cosine to get domain and range of inverse cosine. And it's what you're actually seeing. Negative 1 to positive 1 are the x values, and 0 to pi are the y values. Okay, so cosine is a little bit different. For cosine, the angles we're allowed to get for answers are from 0 to pi. They're in the first and the second quadrant, rather than being in the first and the fourth. Okay? Everybody got that? All right, what about tangent? So does tangent, as is, pass the horizontal line test?
No.
No.
But one of them does.
Okay.
If you just one. 1 second.
So, again, what do I have to limit my tangent to in order to get a piece that does pass?
Negative pi over 2 to pi over 2.
Okay, so basically I need to limit to one curve that's between the asymptotes. Right? Then I'd be fine. So I just need this one curve right here. Okay. Now do I have something that passes my horizontal line test?
Yeah.
Yes. So, tangent of x has a domain of what?
Negative pi over 2.
Yeah, and notice here that this one's going to be parentheses
Yeah.
because that point's not actually included. That's where my asymptotes are. So negative pi over 2 up to a positive pi over 2 is now my restricted domain, but with parentheses this time. Range for this one? Yeah, all real numbers. Because there's no limit to how high up or down we could go. All right, so let's flip that one. So inverse tangent looks like this. A little bit like cube root. A little bit. Okay. Except that it can't keep going up and down as far as it wants to. It's limited. Okay, but it's got that kind of shape to it. What now is my domain for inverse tangent? And what's the range going to be? So tangent and sine actually end up with the same range. The same kinds of angle answers are allowed for both sine and tangent. It's just whether the endpoints can be included or not. But otherwise, everything in between is the same. So tangent is also a first and fourth quadrant function. Inverse tangent is. Okay? Negative pi over 2 to positive pi over 2. I can get answers from the first or the fourth quadrant for inverse tangent. So inverse tangent and inverse sine are going to act very similarly. Cosine is the one that's a little different because those answers can go from 0 to pi. Okay? All right, so as a quick just sort of summary here, when we're talking about inverse trig functions, there's actually two kinds of notation you can use. They both mean exactly the same thing. I think it's really more of a period of time thing as to which one is which. think this one is an older version, and then this is something a little more modern, a little more recent, okay? But they both mean the same exact thing. So the way I was writing it on our examples there was using this little -1 that looks like an exponent, but it's not. Because if it was a -1 exponent, we'd be talking about 1 over sine or 1 over cosine, and that is not what inverse is. Okay? So the little -1 is our symbol for inverse. This is the inverse sine, the inverse cosine, the inverse tangent. The other way of indicating the same thing is to put an ARC out in front of it. So arc sine, arc cosine, arc tangent. Okay, those also all mean inverse functions. And so again, what we mean when we say we want the inverse sine of x or the arc sine of x, what we mean is if y is going to equal the inverse sine of x, if and only if taking the sine of the y will give you the x value. So remember, in inverse trig form, the y now is our angle. And so this is saying this is a true statement if and only if taking the sine of that angle gives me this x value I was taking inverse sine of. That's the back and forth. And that's the way it works for all three of these. If taking the regular trig function of that angle would have given me that number you were taking inverse trig function of, we're all good. Okay? And so now just to fill this in and kind of see it all in one place, excuse me, our domain for inverse sine, what did we say? -1 to 1. Range for inverse sine?
Pi over 2, pi over 2, brackets. Not specified anything to say.
Inverse cosine domain?
-1 to 1.
And range?
0,
Pi,
pi, brackets.
And then inverse tangent?
Parentheses. Negative.
And range?
What is this a
Negative
brackets?
pi over
Negative pi over 2,
No,
pi
pi
over
over 2.
Is it parentheses?
Parentheses.
Parentheses.
Oh,
Tangent,
right,
what do I
because
want?
we can't reach those parentheses.
Yeah, because this is where the asymptotes are, right?
Mhm.
So we can't include them on the tangent.
I didn't think that. Is it?
Okay, so in a nutshell, this is what we're working with today. This is what we have to keep in mind as we start doing some of these actual problems. Okay, I'm going to give you a second to write this down. When you're done writing, then just stand up and take a breather. Okay, and that way I'll know that you're done writing this. And once we've got everybody done, then we'll move on and actually use this for some stuff. But take a minute to write it if you need to, and then you can stand up and stretch and get the food to settle and get the blood back up to your brain. And yeah.
remember once when I was getting up to write stuff on the board, and my foot fell asleep, so I got up and I was like, to the myself.
Yeah. That's terrible because you don't realize it until you go to put weight on it and then you're like down. It's like, okay, awkward.
It's off, probably.
Very sunny.
Yeah, it's kind of nice to see the sun after the cloudy days.
Yeah, it was nice. Really, it was like all rainy and gloomy, and now it's
Yeah,
like,
this morning it was all rainy and now it's all cleared up.
Mirk, can you
Oh,
say
let's
that?
hope it hangs on for the weekend. Nice to have another nice weekend. Last weekend was so nice, especially Saturday.
Did anyone go to the pool last night?
I did. It was really good.
Got it?
Everybody should go. It's really funny.
Go to what? The
I
play?
love playing.
Yeah.
It's really good.
We got tickets for tomorrow night, so.
Same.
That
I'm just gonna
by Saturday, I'll be
buy
like
on
completely
spot.
refined too.
You still practice?
Except everyone will know who did it.
Only 80% of the
Maybe,
spots
I think there's seats
He
left.
said 90%. Who's a liar?
Saturday night
Only
early
because
select
you
because
took
the
the left
last
for the performances.
Oh, yeah.
There's some left, yeah. Milton and Daniel, you still writing, or
No, we're good. We'll have a quiz next month.
Buy two win, man.
Sean and Duncan, are you guys still writing? Are you good? You good? All right, let's keep moving on because we got some stuff to get through and it's gonna take a little time to process. So as you're sitting down, make sure everyone has their own little individual whiteboard, a marker, and a cleaning cloth.
My favorite part of class.
There's rulers in there too, but we don't need the rulers, so. You wanna try one, Ian?
The word is not.
You don't need the rulers. So we use the rulers anyway.
How do you use
Don't
it?
know what you need them for, but if you find a use, I do not care.
John, how do you use Kiki then?
You already.
Just go first.
What does it mean? I thought it just means different.
You don't need the rulers.
Oh, we don't.
Just.
All right,
It's different though. It's like
Yeah, I'll tell you.
so what we need to be able to do is to evaluate these kinds of inverse trig expressions, especially when they're from the unit circle. We have to be able to do them without a calculator. We have to be able to think through what should my answer be. Okay? So that's what we're going to practice here. I've got 6 examples. We're going to do them one at a time. When I uncover it, I want you to think about it and then put your answer on your whiteboard. Do not show me the whiteboard until I call for it. That way everyone gets a chance to think through it and put down their answer before everyone else shows it. Okay? Make sure you give me your answer in both radians and in degrees. Okay? Practice both. All right.
Ready.
Ready?
Oh.
Starting this off with
Okay.
Can we have stuff out to help us on
Well, it's the same.
The call.
What if we convert this to
Sorry, unlock that. I have this expression on the whiteboard.
Yeah.
Here's what I think.
Right? Because we said the range, the output now has to be angles.
I'm so tired.
So you're looking for what's the angle that would have given me square root of 2 over 2 in the first place if I had taken sine of it. So you're trying to work it backwards. All right, let's see them. See if you got it. Wait.
Hold up, I'll even draw a circle. That's what I use in order for. Stack circle. It's totally
Don't think wait is the answer.
It's not. You got it.
All right, most of you are getting it. Most of you are on the right track. So let's think this through for those of you who are still like, wait. Come on. All right, so based on what we said here, what we're trying to do is figure out what's the angle, right? Because angles are now the answers. Those are the outputs from these inverse trig functions. So I'm trying to figure out what's the angle that if I took the sine of it, I would get this number that was in here. So in this case, what's the angle that if I took the sine of it, I would get square root of 2 over 2? That's what we're trying to figure out.
Oh.
Okay? So what's the angle that if I took the sine of it, I would get what's in the parentheses, square root of 2 over 2. And the hand trick still works, right? You just have to decide which finger would I have to put down to end up with a sine that was square root of 2 over 2. So that would be this finger, and this finger represents
45 degrees.
pi over 4, 45 degrees. Now, the other thing you then have to decide is, of the two quadrants I'm allowed for answers, which one is this in? So which quadrant would a positive square root of 2 over 2 be in? The first quadrant. So that means I can just use positive angles. So it's going to be a positive, whoops,
Wait, couldn't there be quadrant?
No.
a positive pi over 4 as the radians, and a positive 45 degrees as the degrees.
Couldn't it also be 3 pi over 4?
Okay, can it also be 3 pi over 4?
Because the range is pi over 2. Negative pi over 2.
Right.
Exactly.
Oh.
That's why we have to keep this range in mind. Alright? Because in the unit circle, yes, 3 pi over 4 also gives us square root of 2 over 2 as an answer. But it doesn't fit within the allowed range.
Right.
If I go that far, I'm not talking about a function anymore. I can't even do it. Right? So that's why we need to know these reduced ranges that we ended up with, because those dictate the kinds of answers I'm allowed to get to these expressions. So 3 pi over 4 is outside of my range. I can't use that as an answer. I can't use that angle measure. I can only use the positive pi over 4 or positive 45 degrees. That's the only one that's within the negative pi over 2 to positive pi over 2 range that we said we were allowed. Okay? Make sense? All right, let's try another one.
Okay.
Wait, would that work though? Because it's the 0 to pos.
No, the range
No,
is
no,
0
that's
to
the
pi.
range. Sorry.
You know? It still works. It's just it's getting very fake.
Yes.
Boom. Oh, I'm not supposed to get video.
Yay, same answer.
5 pi over 6.
Jeez, boilers.
Doesn't work. House doesn't work.
And it can't be negative pi over 6. Yes.
Oh, yeah.
That would be wrong.
All right, let's see what you got. See how we're doing.
Mine even comes with the crap. Whoa. His is very.
Wait, was it actually was it 5 pi over 6 or was it?
All right, looks like most of us are on the right track. Good. All right, so we can still use the hand to get the reference angle. So which finger do I need to put down to get a square root of 3 over 2? The ring finger. Okay? So which angle does that finger represent?
30 degrees.
30 degrees or pi over 6. So as a reference angle, we know we're dealing with pi over 6. But now, of the two quadrants we're allowed for inverse cosine, which one has negatives?
The second one.
The second. So I can't just go with pi over 6 because pi over 6 would have given me a positive square root of 3 over 2. So I have to figure out what's the corresponding second quadrant angle with a reference angle of pi over 6 so that I get the negative square root of 3 over 2. And that's going to be the 5 pi over 6, or as degrees, 150 degrees. Okay? And is that within our allowed range for inverse cosine? Yes, because we were supposed to go from 0 to pi for inverse cosine. So 5 pi over 6 is fine. Okay? 7 pi over 6, which also would give you a negative 3 square root of 3 over 2, not fine, because that's outside of our range. Okay? All right, next one. So in case that's not clear where you're sitting, it is an inverse tangent of a negative square root of 3.
You want it in positive or negative angle measurements?
Want it in whatever works.
I think that's right.
All right, let's see them.
Hold up.
All right, well, we got a lot of stuff going on out here. Okay, so look around the room. Look at some of the answers.
Uh-oh.
Is it true that a tangent of 2 pi over 3 would give me a negative square root of 3? Is that a true statement?
That's true.
No, it's out of the range.
It's
So is
true.
it a true statement?
Yes.
Yes.
But
But
it's out of the range.
is it within the range?
Nice.
No.
So it's a trick.
Okay. So I can't use the second quadrant angle.
We use the fourth.
So where's the other quadrant where I get negative tangents?
Fourth.
Fourth quadrant. Okay. So fourth quadrant. Does that mean I can use 5 pi over 3?
I think. No, it would have to be a
Negative
pi over 3 because that's to be in the range.
Okay? Because 5 pi over 3 is also outside of the range of negative pi over 2 to positive pi over 2. So yes, I need a fourth quadrant answer, but I need it as a negative answer, not as a positive answer.
What is it?
So,
It's this one.
okay, so listen up. So the beauty of tangent and sine is that once you figure out your reference angle, okay, so for square root of 3, which finger do I need to put down so that I end up with a tangent of square root of 3? The pointer, which is my pi over 3 finger, right? Because then it's sine, square root of 3, over cosine, square root of 1. That's going to end up being square root of 3. Okay? But square root of 3 gives me pi over 3 gives me positive square root of 3. How do I get negative square root of 3? I just do the negative reference. right? Because the way the allowed range is set up is that it allows me to go negative pi over 2, which means I had to go clockwise to get there, up to a positive pi over 2. So, once I decide what the reference angle for positive is, if what I really want is negative, then I just need to do negative reference angle. So anytime that's negative, I just say it's negative whatever the reference angle is, and that's within the range. It gives me the fourth quadrant angle, but as a negative angle, which puts it within the allowed range. Make sense?
It makes sense.
And then negative 60 would be our degree answer to go with that. Okay? So this is where it kind of starts sinking in, like, wow, I really have to think about this and be careful about what I'm putting down for answers, because I'm not allowed to just use anything. Right? I have to get angle answers that are within the allowed range. Okay?
Keep going.
All right. Couple more. Now we're getting the hang of it.
Oh, it's one.
Yeah.
All right. This one should be pretty easy. Let's see them.
Super duper.
Ooh, some of you are getting lazy on me. If you do this on a quiz or a test, you're not going to get full credit. What are you supposed to be giving me for an answer? Radians and degrees. Some of you are just giving me one or the other. Bad habit. Now, because they all fixed them when I started talking. All right, so pi over 3 is the reference that gives us 1/2 for cosine. Since it's just positive cosine, I just stay with that pi over 3 because that's my first quadrant, and the degree equivalent will be my 60. Okay? What about that one?
Don't up yet, man.
All right, this one should be another fairly easy one. Let's see.
Yay! Everyone.
Looks like it.
All right, pretty good. So again, which finger would I put down now so that my sine and my cosine are the same? It's the middle finger, right? So that's the pi over 4 finger. And since it's just positive 1, I'm just going with positive pi over 4. And then positive 45 degrees. All right, last example for today. Hopefully this will be enough to have you feel fairly confident going into homework.
It's beautiful.
It's true art.
All right, let's see them.
It's backwards.
Yeah, that's a beautiful grid.
You have
Oh,
right.
there you go.
yes, sorry, I was pointing at my table.
All right, so just like the tangent up here, once I take, okay, 1/2, what's my reference angle? It's going to be pi over 6. But since it's negative 1/2, for sine I just have to go negative pi over 6. Tangent and sine work the same way. So negative pi over 6, which is a negative 30. Those are my answers for inverse sine. Any questions? Starting to get the feel for it?
Yes.
Okay, good. Now, obviously these you should be able to do without a calculator because they are values off of the unit circle. So you should be able to figure out the corresponding angle by thinking. But not everything's going to be that clear cut. So I don't need you to do this right now because I want to go on to something else and use the time on that. But I just want to ask, is anyone not clear about where to find your inverse trig on your calculator? Has everybody stumbled across it under the trig button when you do the trig stuff? Okay, so it's just a matter of plugging it in, finding your inverse trig under the trig button, just like a regular trig is, putting in the answer. But keep in mind, if I'm asking you for both radians and degrees, you're going to have to play with your settings, right? You're going to have to be in one setting and then do all of your problems, and then go and change it to the other setting and redo all of your problems so you can get both answers. Because the kind of answer it's going to give you for your angle is going to depend on what your setting's in. Okay? So be aware of your settings to know what you're starting with, and then change your settings to get the other half of your answer.
Can you just keep it in radians and then make sure to always put like the little circle or the degree mark?
No, because this is not an angle measure, right? This is the result. You're going to get an angle measure. So putting a little degree sign after that's not going to help.
Okay.
So it's got to be about what your calculator's set in.
Can you use calculator?
Sorry?
Can you use converting?
Can you use converting? Is that what you said?
Okay. Can
You
do
mean just
radians
like
and then-
if you found degrees and multiply everything by pi over 180? Yeah. If you want to.
But that'd be easier then,
It sounds
than
fascinating.
changing settings.
It's one change. Like if you go through all your problems with one, punch, punch, punch,
Oh,
punch, and then you make one change and hit make default, then you just go punch, 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 punch again. So I don't know that one's necessarily a whole lot easier than the other. Do whatever one you like. It's not gonna matter. Okay?
So is
All right. Another question? Sorry.
there part of the homework that you want us to do like by hand, like we just did, or is
It
that-
will tell you in the directions.
Okay.
So the ones that we did like this, I know they're all covered up again, but it'll say without a calculator.
Okay.
And then this one, it'll say use your calculator. So your directions in the book will tell you. Yeah. Okay. So the last part that we need to be able to do for homework are compositions of these. So theoretically, if I take the function of an inverse function or the inverse function of a function, they should cancel each other out and I'm just left with that x, right?
Sure.
So if I have x squared and I take the square root of it, the square and the square root cancel each other out, I'm just left with x. Theoretically, that's how it's supposed to work.
Realistically.
But,
Because there are limitations.
exactly, because of these limitations with the trig functions, we have to be careful about that with inverse trig because it doesn't always work to just cancel it out. Okay, so we have to continue to think about those limitations when we're trying to decide, can I just cancel out the sign and the inverse sign? Or is that not going to work? So there's a couple of quick examples here. If I had inverse sine of the sine of pi over 4, then this one would work. I can just cancel out the inverse sine and the sine, and the answer I'm left with is pi over 4. Okay? But if I tried to do something similar like this, where I have the inverse cosine of the cosine of 7 pi over 4, that doesn't work. Because what I'm saying then is that when I take the inverse cosine of this thing, I end up with a 7 pi over 4 as an answer. But 7 pi over 4 is not allowed as an answer to an inverse cosine. It's outside of the range. See what I mean?
Yes.
Okay? So because this is outside of the range for the kind of answer that's allowed for an arc cosine, for an inverse cosine, I cannot just cancel this time. So what I would have to do is actually work this out. I would have to think through what is the cosine of 7 pi over 4, and then take the inverse cosine of that to figure out what the real answer is supposed to be. Okay, so let's do that for a second. What is the cosine of 7 pi over 4? What quadrant are we talking about?
Fourth.
Fourth, right? 7 pi over 4?
Should be root 2 over 2.
So we're going to have a positive root 2 over 2. So this becomes positive root 2 over 2. Now, what is the inverse cosine of root 2 over 2? Pi over 4. Not 7 pi over 4.
Is it always going to be the reference angle?
If it's in radians, yeah, it should be either the reference or the negative
same.
of it, you know, either the second quadrant or the fourth quadrant, depending on which one you're doing. But it should be related to that reference angle.
Okay.
Okay, get the idea?
Yep.
So we have to be careful about just canceling things out, because just canceling isn't going to work all the time. Let's see, so we're going here. So you don't need to copy this right now. It's in your book. If you want to copy it into your notes, you can do it as part of the homework when you're working on it, or you can just refer to it as you need to, because I want to move on and actually do a few more problems. But this is basically what it boils down to. It depends a little bit on which one's on the outside and which one's on the inside. Okay? If it's the sine on the outside and inverse sine on the inside, then I just had to make sure that what I'm taking inverse sine of is something within the domain of inverse sine, which means it's got to be between -1 and +1. Okay? If it is, then I can cancel. I think what's a little bit more tricky is when it's the arc sine, the inverse sine on the outside. Because that's when you have to be really careful about what angle am I using here to take the sine of in the first place. Because that angle has to be within this -pi/2 to +pi/2 that we're allowed. If it is, then just canceling out is fine, because now you're saying inverse sine of something is going to be this allowed answer. That's all good. But if that y value ends up being something beyond that interval, then you have to actually work it out. You can't just cancel. Okay? Similarly with cosine, if it's cosine on the outside and the inverse cosine on the inside, then we just have to make sure that, again, we're using a number between -1 and 1. If it's the inverse cosine on the outside, then we have to make sure that the cosine is being done on an angle that's between 0 and pi this time, rather than -pi/2 to pi/2. It's got to be between 0 and pi. If that's the case, canceling's fine. If it's beyond that interval, then we have to work it out. Okay? And then tangent is a lot like sine, except that our x value here can be any real number. So having tangent on the outside is actually really easy, because you can do anything for x and you can just cancel tangent and inverse tangent. Beautiful. But when you have the inverse tangent on the outside, then you have to be careful again about, so which angle are we dealing with? Is it something between -pi/2 and +pi/2? If it is, cancel. If it's not, work it out. Okay? All right, so a couple of quick examples of that. So would this be something that I would be allowed to just cancel the tangent and arctangent? Or do I have to actually work this out?
Just cancel.
This is when we should be able to cancel. Because this is
X is real answer.
this one. Whoop, wait, I'm on the wrong one. There we go. This is this one, right? Anything can go in for X, and I can cancel them out and get X. So that's what's going on here. I've got the tangent of an inverse tangent. I'm allowed to put anything in there as long as it's a real number, and things will just cancel. The answer is -5. Okay? How about that one?
No.
Can I just cancel arc sine with sine?
No.
No, why not?
Because it's not in the radian.
5 pi over 3 is outside of the interval from -pi/2 to +pi/2. Okay, so I need to work it out. Where is 5 pi over 3?
Fourth quadrant.
The fourth quadrant. So in the fourth quadrant, I can think through and go, okay, so sine is going to have to be negative. What number is it? But you could also stop for a second and say, wait. Fourth quadrant. I'm allowed to do sines in the fourth quadrant.
There's negative.
So what if we change that from a positive 5 over 3 to the very coterminal negative pi over 3?
Yay!
Wait, and then you
Get
just,
to me.
then it can cancel.
Yeah, I could.
And then.
We was wrong.
Then I'm allowed to cancel,
Oh.
but negative pi over 3 becomes my answer, not the 5 pi over 3. So if this ends up being something that's actually in the quadrant you're allowed, like it's in the fourth quadrant, then just switch it to what it would be as a negative, and then you're all good. Canceling works again. Okay, but if you don't notice that, this is our mantra. When in doubt, work it out. Okay? If you're not sure whether you've got a situation where you can just cancel, then you better be going through the process in your head to work it out and see what you're going to get. Okay? All right, how about this one? Can I just cancel those two?
Yeah.
Yes.
Yeah.
Pi is pi inclusive?
Guys.
So it's yes.
It's okay, I got tricked on this one too. When cosine is on the outside and the inverse cosine is on the inside, what is the restriction on x?
Negative
It's not the angles,
What?
right? Inverse cosine, where am I at? Yeah, this one, okay? Inverse cosine
Oh.
doesn't work on angle measures, it works on the result measures,
Right.
right? So this is actually saying, I want to take the inverse cosine of like 3.14, which is outside of the -1 to +1 range. So this isn't even possible. Whoop. You can't even do this one, because there's no way to take the inverse cosine of pi in the first place. Okay? All right, last couple of examples here. So one more type of composition problem is when we're trying to do it with different trigs. Like instead of it being tangent and inverse tangent, we're taking tangent but inverse cosine. Okay? And we're supposed to come up with an answer. And notice, we're taking inverse cosine of something not very unit circle-ish. Right? 2/3 is not one you find on the unit circle. So how am I supposed to do this?
Work it out.
You have to do it.
Yes, when in doubt, work it out. But how?
You do arctose first. And
Use your
calculator.
Exactly. We're going to draw a triangle. Okay? And here's how the triangle is going to help us. Okay, follow this real quick. This is the angle that I'm going to label. Because what does the arc cosine of anything give me? An angle. Right? So we're saying this is going to be my angle, and honestly, this angle is equal to whatever arc cosine of 2/3 is. Now, it's a weird way to label an angle, but stay with me here for a second. That's what it is. Okay? Based on my definition, that angle is supposed to be whatever angle would give me 2/3 when I took the cosine of it.
You don't even need the
Right?
angle.
So that means this angle has to be whatever angle would give me 2/3 when I take the cosine of it.
Exactly.
Cool.
You don't even need to know the
Which means I can now figure out what the third side is and figure out whatever this is supposed to be.
This is screwed.
So it's going to be
No.
square root of 5,
Just kidding.
which means the tangent
Tired.
of that angle now is going to be what?
Root 5.
2.
Whoa.
Whoa, everyone. Just got
Dark magic.
That's how you work those out. You have to think through the triangle to set it up. Now, what if this had been negative? Well, then you just flip the orientation. I'm trying to think if I actually set this up correctly for first quadrant in the first place. Yeah, so you just, one way you can do it is like, since I want the tangent of this, if it's negative, then tangent would be down here, so you would flip it. Or the other way is to just think through, okay, so tangent would mean I was in this quadrant instead of that quadrant, so then what would the sign have to be? Okay? But that's the idea, that's how you work through it. Now, let me really blow your mind.
Ah. Cosine of negative 3x.
Yes. Would be like,
Would it be
Now,
3x?
The tendency is to want to be like Nicole and go, why?
So is x
But
3x.
it's still the same thought process. Make the triangle. Whoops. Helps if I have a pen. Here we go. Make the triangle. Here's my angle. The angle really represents what?
Cosine
The inverse cosine of 3x.
arc
Whoops.
cosine.
Cosine 3x, right?
Yeah.
Well, 3x is the same as
3x over 1.
3x over 1.
So x is
So as a cosine, what can I label? 3x would go the hypotenuse.
What? No.
Oh, no, my bad, my bad.
One would go on the hypotenuse.
There we go. 3x is going to go, that was kind of cool. Woo. 3x, right there.
Yeah.
Hypotenuse is going to be
1.
1.
Hey, it's unit circle.
So what does that mean for this other side? 1 minus 9x squared. So now, what is the sine of this angle? Based on what I now have labeled.
1 minus 9x squared.
That's the best we can do. That's all we're going to get.
It's funny that this angle is the unit circle.
Yep. Because theta is the angle I get from the inverse cosine of whatever 3x was.
Oh,
Right? That's what that angle is. So, yeah, we're just taking the sine of that theta, and in this case it's 1 minus 9x squared. Yeah.
Why isn't it square root of 1 minus 9?
Because the root of.
I don't know, why isn't it? I was going by what you said.
Because why
Lead me
would
astray.
you want to do that?
really?
Yeah, it should be square root,
What?
right? Because we're taking hypotenuse squared minus leg squared equals this one squared. So to get this, we got to take the square root. So yeah, it should be square root of this. But it's still over 1 when we do the sign, so this is still our final answer. Okay? So when you get these situations where you're doing compositions with different trig functions, you have to think in terms of the triangle. When it's the same trig function, inverse sine with sine, inverse tangent with tangent, then you have to just think through, can I just cancel? Or do I have to actually work it out? And those will probably be numbers from the unit circle that you can actually work out. Questions?
Need some time to digest it.
Can we have a moment to just let our mind be on?
You actually have about 7 minutes right now. So what I would recommend is you take a couple minutes, go to Canvas, see what the problems are, go to the textbook on Canvas, and just scan through them and see if anything just looks totally bizarre to you that you want to ask about before you leave. Okay? Whether you actually start any or not is up to you, but at least take a scan through the assigned problems and see if any of them just look totally bizarre that you want to ask about before you leave. Okay? Because you've got about 7 minutes before we're done.
Remember what?
Yes.